Example 4, vertical and horizontal. Notice transformations. Translations mean shifts. We're not talking about shifts now. Now we're going to be talking about stretches and shrinks or expansions and compressions. So this happens when you multiply by a number. So here's the rule. If the number is greater than 1, it'll stretch the shape as long as we're dealing with vertical, which would be telling the truth. The outside, the y's tell the truth. So think about it. If you took the number 10, and let's choose any number greater than 1. Let's say 2. If you multiply it by 2, what happens to 10? It grows and it becomes 20. Well, I mean, you can play this game all day long. All right, let's say, again, we're taking 10, but let's now, instead of multiplying by 2, let's multiply by 3. What happens? It grows and becomes 30. It keeps growing. So if the number is greater than 1, it's going to be an expansion or a stretch because the number is getting bigger. Conversely, if the number is less than 1, say 1/2, what happens? The number shrinks. It becomes 5. Or let's do this again. Let's say it was 1/5 you multiply by. Well, that would give us the value 2. So if the number is less than 1, it shrinks. If it's greater than 1, it's a stretch. Unless, of course, you're dealing with horizontal, because remember, horizontal lies. Then it would be the opposite. So here's what happens here. You take the a, and what you're actually doing is not multiplying by a, but it's reciprocal, which in this case would just be a. If we have a over 1 here, it would actually be multiplying by 1 over a. So if it's horizontal, and let's say in the equation you see this, like 1, or f of 5x with the 5 on the inside, this would actually be multiplying 1/5 times every x value, because you do the reciprocal. Let me do one more here. Let's say the number was 1/2. Well, that would not necessarily be multiplying by 1/2. That's what it tells us, but it's lying to us. Instead of multiplying by 1/2, it's actually multiplying by 2 over 1, which is 2. The truth is that multiplying by 1/2, the lie is it's actually dividing by 1/2. And when you solve, you'll get 2. So the easier way of thinking, instead of multiplication / division, is just to think, flip it. If it's not a fraction, make it a fraction by putting a 1 underneath. So one more. Let's say it was multiplying by 3/2. 3/2 look like it's greater than 1, so it looks like it should be a stretch. That's a lie. It would actually be multiplying by 2/3, which would be a shrink or compression. So now let's look at how we actually solve these values. Example A, identify the parent function of g of x equals negative absolute value for x. So absolute value is our parent function, absolute value, and that's what it's going to look like, a v. And we have two transformations here. I have a negative on the outside. A negative is a reflection. And so on the outside, it's a vertical reflection. And a vertical reflection, if you think about it, goes from top to bottom, bottom to top, which means a vertical reflection is over, if you're going top to bottom, it goes over the x-axis. This v will flip over the x-axis here. This vertical flips down here over the x. Okay, now here on the inside, we have the number 4. Now this looks, since it's inside, it's horizontal, and the number is bigger than 1, so you would think it should be a stretch. Remember, horizontal lies, the inside lies, the x's always lie. So instead of being a stretch, it's actually going to be a shrink or a compression. And the factor is not 4, you take the reciprocal. Since 4 doesn't have a fraction, I'll make it a fraction. So what is the reciprocal of 4 over 1? It is 1/4. So here's how you would solve this. If you look at this graph has been horizontally compressed, and it's also been reflected. So if you went by PEMDAS, here's what happens. It says to multiply by 4, but we know that's a lie. We're actually multiplying by 1/4, and that's with the x. What you do is if you chose any point, I'll just choose this point right here. That point looks like it's left 1, 2, 3, 4, up 1, 2, 3, 4. That's the point, -4, 4. Since it's a horizontal shrink by factor 1/4, you multiply the horizontal value by 1/4. Now, horizontal is the x. So I would take 1/4. I take that -4, and I'd multiply that by 1/4. This will give me my new point. Whoops, that's how I spell new. Here we go. Here's how you get the new point, is you multiply that by 1/4. Now, -4 times 1/4 is -1, and so we get -1/4, which would be right negative 1, 4, which goes to there. So that's the shrink. Now, when you look at the next thing that you're supposed to do, it was a reflection across the x-axis. So this point then gets reflected down across. Now, since we're reflecting the y's, this 4, when you reflect the y, what happens is your y value changes from positive to negative. So it goes to negative 1, comma, negative 4. And so now if I look over here, if I go left 1, down 1, 2, 3, 4, yes, I do have the point, negative 1, negative 4. So that's how that transformation works. Let's try another one, part B. A g of x equals 2 times all of this. Describe how the graph g of x and f of x are related. Then graph g of x on the same axis. Now, here, this is a little tricky here in this part. So when we see this, this is actually, we could rewrite this as negative x plus 2. Now, I know what most people are saying. That's a plus 2, but it's inside, it's going to lie. The truth is, whenever we solve this, the reason it seems like it's lying is because what happens mathematically is you solve it for x. Now, if I wanted to get x by itself, I would just add it over and say that 2 equals positive x. What I did there, so you're not confused, is I added an x to both sides. That's what it just did. Okay, that means this is actually going right 2 units. So that's inside with the PEMDAS. That happens first. Everything goes right 2 units. But actually, even before that, we have a negative x, which means all my x out values flip. And so the first thing I would need to do is flip all these x values. So I'm going to write what these values are. This one is left 1, 2, 3, 4, up 2. So that's negative 4, comma 2. This point is negative 1, comma negative 1. This point is right 1, up 1, so it's 1, comma 1. This one is right 2, down 2. Right 2, down 2. Okay, so now the first thing that happens is I flip. So if I point out these transformations, this is a reflection, reflect x values, which means it goes across the y-axis, because I'm flipping from left to right and right to left. This is going to say right 2, as we saw right here. When we solve for x, that was a little tricky because of the negative x. This right here would say we're going to go up 1. And we're also, it doesn't look like a 1, let me just, there. And here I have a vertical stretch, since the number is bigger than 1. Stretch by factor 2. So here's what we're going to do, PEMDAS. First, you reflect the x's. So this point, if I just wrote out all the points, I'm going to write them out right over here. I have negative 4, comma 2, negative 1, comma negative 1, 1, comma 1, and 2, negative 2. The first thing that happens, according to PEMDAS, is I start in the inside and inside the parentheses, I reflect my x's. So all my x's become flip signs. So I have this point, 1, negative 1, negative 1, 1, and then here it would be 2, comma 2. So I flipped all my x values. The next thing is I go right 2 units. So now I go right 2, still on the inside. So it becomes 6, comma 2, 3, comma 2. I'm sorry, 3, comma negative 1, 1, comma 1, and finally 4, comma 2. The next thing I would need to do is multiply all the y values by 2. So let me get this over a little bit more. I'm going to multiply all my y values by 2, which means my next point would be 6, comma 4, 3, comma negative 2, 1, comma 2, 4, comma 4, and finally, what's the last? Move all my y values up 1 more. So I'm going to have my y values go up 1 more, so this would be 6, comma 5. This would be 3, negative 1. I'm running out of room here. This will be 1, 3. And this will be 4, 5. And so now I would plot these. So 6, 5, right 6, 5 would actually be a point right there. 3, -1, right 3, down 1 is right there. 1, 3, 1, 3, and then 4, 5. 1, 2, 3, 4, 5. And before I plot this last one, I just realized I wrote this backwards. It was supposed to be 2, -2. So I'm going to erase this last one really quick and do the same transformations again. That point will be incorrect. Let's do that one again. So the first step was writing it correctly. Then what did we do? We reflected the x's. So this would become -2, -2. And then the next one was we added 2 to every x value. So that would be 0, -2. And then the next step was we multiplied the y's by 2. So it would be 0, -4. And then finally, we added 1. So it would be 0, -3. So my last point is 0, -3. And so if I connected my graph here, this would be the actual picture. Let me do it in green. We go from here to there, there, to there, there, to there. That's how this transformation would take place, step by step. Now you have one to try.